to study the parts of a compound microscope. Parts of a compound microscope. The compound microscope consists of two main parts, a foot and a limb. This horseshoe-shaped basal part of the microscope is called a foot. Foot supports the limb. The limb bears a stage. On the stage, the slide is placed for observation. There are two spring clips for holding the slide in one position. Below the stage lies a mirror which focuses the light rays. The light rays pass through the hole located on the stage. These light rays illuminate the slide kept on the stage. You can see a substage in between the stage and the mirror. This substage consists of an iris diaphragm and a condenser. The iris diaphragm is a wheel-shaped metal disc. This disc regulates the size of the aperture. Through the aperture, the light rays are reflected by the mirror to reach the condenser. The condenser consists of two or more lenses which receive the light rays coming from the mirror. These rays are converged at the level of the stage. A compound microscope is able to increase the magnification by bending light through a series of lenses. The limb towards its anterior end is provided with an optical tube. This optical tube can be moved up and down by rough and fine adjustment screws. Rough adjustment screw is bigger in shape, while the finer adjustment is done by the smaller screw. The upper end of the optical tube carries an ocular eyepiece. Eyepiece usually have 10x lens. This is called ocular lens system. The lower end of the optical tube carries a revolving nose piece provided with two objectives. Objectives are also lenses, one of low power. It is called 10x. The other objective is called 45x or high power. Some microscopes may have 100x objectives too. The objectives can be brought in line with the eyepiece. So we can see that a compound microscope consists of two lens systems, the objective lens system and the ocular lens system. These lens systems magnify an object due to their combined power. The objective lens focuses the image of an object in the optical tube of the microscope. This is called the first image. The first image is then magnified by the eyepiece, which has ocular lens. We place our eye on the eyepiece while observing the slide. The final magnified image of the object is focused on the retina of our eye. The final image is formed by the combined actions of the lenses of objective and the eyepiece. Thus, microscope is used for both magnification and resolution. Magnification of a microscope. Magnification. The magnification may be defined as the ratio of the length of the final image to the length of the original object. Suppose the length of an object which is seen through low power objective, that is 10x power, and an eyepiece with similar 10x power is 1 mm, then the length of the final image that is formed will be 1 into 10 into 10, that is 100 millimeters in length. Resolving power of microscope. Resolving power. The fitness of details of the image seen with a microscope is called its resolving power. The resolving power may be defined as the smallest separation at which two objects are seen. If the resolution of the microscope is good, then only we can observe the microscopic details of our biological slides. Instructions regarding the use of a microscope. Now carefully follow the instructions before you handle the microscope. While lifting the microscope, use both the hands. Hold the microscope by its limb with your right hand while supporting it from below near the foot with your left hand. Use the microscope in vertical position only. Before observing a slide, look through the eyepiece and bring the eyepiece and the low power objective in one line. Adjust the mirror. Always use the concave side of the mirror for reflecting the light from its surface in the microscope. Place the prepared slide to be examined on the stage of the microscope. Be sure to wipe the slide with the help of blotting paper from lower side. Do not place the wet slide on the stage of the microscope. help of rough adjustment screw, raise or lower the optical tube till the object comes in the focus. Place both the clamps on the slides so that now the slide does not move from your required focus. Adjust the intensity of light by using the iris diaphragm. If the object is to be seen under high bar, turn the objective of high bar without disturbing the previous focus and adjust the focus with the help of the fine adjustment screw. Special care should be taken to see that the mounting medium does not come in contact with the lens of the objective. Do not forget to clean the microscope before leaving the laboratory.